Hello, and welcome to Elation Professional's Lighting Systems Design Training Series. I'm Bob Mentele, Vertical Market Manager here at Elation, and I'll be taking you through the training today. In today's episode, we're going to be looking at the key lighting system best practices, and more specifically, fixture placement and layout. So, without further ado, let's get to it. The first topic we're going to cover is the angle of light. The angle of lighting is one of the properties or qualities of light that we as designers and specifiers have to decide upon when putting together a system. In any system, the front or the key lighting is going to be your priority. That is going to be your main source of illumination on the stage or on the subject. So once the solid key light coverage is obtained, we can move on to the other aspects. For the most natural appearance, when we are placing lighting fixtures, we want to elevate them 30 to 45 degrees from the subject or the focus point. What that placement does is it emulates natural sunlight in the environment. And it also helps to give shape and definition to the subject. If we are laying out a lighting system that will be used for video, we're going to want to elevate those lights on the lower side of that 30 to 45 degree angle. At 45 degrees, the shadows created in the face can be a little bit too harsh for a camera environment. The camera sensors are much more sensitive than the eyes are, and the camera is typically closer to the subject than in a live performance. So we're going to want to lower that angle of elevation, and we're going to help reduce the shadowing in the eye socket. In that front lighting system, we're also going to want to place two fixtures off center axis 45 degrees from each other as well. When utilizing this two front light system, one fixture is typically going to be at a brighter intensity than the other. That fixture that's going to be the brighter intensity is going to provide the majority of the illumination, and it also is going to be referred to as the key light. And the fixture opposite the key light is going to be lower in illumination level, and it's coined the fill light because what it's going to be doing is filling in some of the shadows that the key light creates. And when adding in a follow spot, you're going to want to place that light at an even lower angle, around the 20 degree mark, to really remove a lot of that shadowing on the face. The secondary priority in a lighting system is going to be back or top light. In video applications, this is especially crucial as it helps the subject stand out from the background and gives more definition to the entire stage picture. That backlight on the far right hand side in the diagram, you can see it's not directly on top of the subject. You're going to want to place it about 15 degrees off axis from the individual so that it is creating a framing effect and not actually illuminating the top of their head and their face. That can detract from the natural appearance of the front light. When working primarily in theatrical or dance applications, another priority is going to be a side light system. Side lighting, very similarly to backlighting, helps to frame a figure, but the difference is that it frames and enhances the entire form of the performer, the entire figure of the performer, whereas backlighting is really just focusing on the head and shoulder area. Side lighting also does light up the body of the individual, whereas backlighting, we don't want any spill on the audience facing side of the performer. That is not the case with side lighting. As far as where side lighting comes from, side lighting is going to be placed directly off stage of the performer. Later in the presentation, we're going to review some common theatrical lighting positions, and in that view, you will see dance booms, and that is where a majority of our side lighting is going to be placed. One primary angle for the side lighting is going to be very similar to our front lighting in that you will place the side lighting at a 30 to 45 degree angle from the subject. This angle is a very realistic angle and can be quite useful in a majority of applications, not just theater and dance. We can also lower the side lighting to be even with the head and torso of a performer. In this case, this is going to be referred to as head highs because they are placed at head level of the performer. These are going to be focused on the head and torso and really help to frame and light that portion of the performer. And then we have what are referred to as low sides. This side light angle is covering for two different positions on a dance boom, one being the mid highs, which are usually placed around the waist to thigh level, and the other being the shins. The shins are placed at shin level, and both of these angles are going to be pointed slightly upward so that they don't graze the floor at all, and they're going to provide a fairly unrealistic side light, but is going to be used heavily in those dance applications. Typically in dance, you're going to use a combination of your head highs and your low sides to fill a majority of the framing on stage, and then supplement with other lighting angles. So in the next couple slides, I wanted to show you an example, a virtual example in my capture visualizer. This first image is showing a subject in a studio using front light only. Two front lights, one slightly more intense than the other. You can see the subject is wearing a black shirt in front of a black background, which is not something I would recommend, but to help to enhance the example, I colored him as such. So we can see the individual, they are well lit, however, there's not a lot of depth and dimension to the stage picture. So what we can do is add a blue backlight. It helps to frame the shoulders, frame the arm, and the head. It helps to bring that individual out from the background and makes them more dimensional, makes the picture more dimensional, as you can see. Another thing that comes up quite often from individuals designing a system is what is the proper illumination level for the stage or for the space that I'm working on? How do I know when I have enough? Well, the average illuminance level during a typical stage production can vary greatly, from 10 to 200 foot candles. And the level desired is going to be dependent on the needs of the atmosphere during the production versus just plain visibility. The lighting in a theatrical production is often used to enhance or accentuate the mood or add tension or extra drama to a specific scene. So the lighting level can vary greatly. But on average, acting areas are going to have between 50 and 100 foot candles. When lighting for a studio application, the luminance levels are going to be a little bit more consistent because we're dealing with cameras and a very controlled environment. So we are also not necessarily as worried about creating any sort of mood or enhanced dramatic feel. So we're going to be looking at ranges between 30 and 50 foot candles for the cameras. And very similarly to stage productions, concerts are going to require lighting levels in the range of 50 to 100 foot candles. But again, those levels may vary depending on the desired atmosphere during the performance. Maybe it's going to be particular to a specific performer or a specific song within their set, so that can vary as well. Okay, let's get to laying out our lighting. So here we have a sample stage in a room. The stage itself is 40 feet wide and it's 15 feet deep, so it's a fairly average sized stage. We have to answer a couple questions here, and one of them being, where do I put my lights? And how many lights do I need? And where are they focused to provide even coverage across the stage? So the method that we use is we're first going to define focus points in the stage or focal areas. We're going to break the stage into sections, and each area I use between a 10 and 12 foot diameter space. And when I'm using a drafting program, I literally create a circle that is 10 to 12 feet in diameter. And that is going to be dependent on the size stage I'm working with and the budget, as well as the throw distance of the fixtures, things of that nature. So we're going to simply take those circles and distribute them across the stage. We're going to distribute them evenly with some slight overlap between areas so that we have even coverage. You can see overlap on the left, right, and top or bottom, depending on where it's located on the stage. Once we have areas evenly distributed across the stage, we can now decide where to place our actual lighting positions. The top light locations are fairly easy. We know we need to place them slightly behind the individual. We don't have to get terribly particular in ensuring that it's 10 to 15 degrees off center. We can just place them slightly behind. The front light structure, we are going to want to pay a little bit more attention to. We're going to want to look at the stage, and we are going to want to determine the hang height. What height are the fixtures going to be? And now we can decide what distance away from the stage will provide a 30 to 45 degree angle. The other thing we're going to need to define is the throw distance of the lights from the hanging position. And we can do that with a little bit of geometry. So we all may remember the Pythagorean theorem, a squared plus b squared equals c squared. So we can take the distance from the stage to the hanging position, which in this case it might be hard to read, it's 17 foot 6 inches. And the hang height is 13 feet. Now notice that the hang height is not measuring to the floor. We're not concerned about the size of the light when it hits the floor. We're concerned with it hitting the center of the focal area, which is an individual, not the floor. So we're going to want to make sure that our focal area is about 3 feet off the stage. With that, we have about 13 feet. So doing the calculations, we have a 21.8 foot throw. We can now use that throw distance to calculate the proper beam size that we want to get that 10 to 12 foot diameter beam size, which in our case is going to be a 26 degree lens, or a 36 if we want to make it a little wider. So now that we know what fixtures we're going to use, what lens tubes, we can start by placing our fixtures. Going back to our top view with our defined focal areas laid out, we can simply draw some guides at 45 degree angles from center. Using that guide, one light on each side, we take that guide, we move it to each area, and we place 2 lights in the defined spots. Now, there are going to be some areas that overlap where those angles hit, so we just bunch the light fixtures together. Being 1 or 2 feet off axis from the guide is not all that critical. So we lay out our lighting. We can now easily add the downlights. 1 center fixture slightly behind each focal area. So this is our completed plot for our 40 by 15 foot stage. You can see we have 20 front lighting fixtures because we had 10 focal areas. And this would provide something similar to this visualization here. This is the actual lighting system laid out. And for larger theatrical stages, this is a proscenium theater. The process is the same, no matter the complexity or the size. You can see here I have my 10-foot circles laid out. And what I also do for a larger stage is now you're going to label each area. I use letters to keep things straight. Typical hanging height in these applications are going to be 20 to 25 feet for most theaters that we'll deal with. In the very large professional theaters, you'll have higher hang height. In some high schools, you may have a shorter hang height. So, when working in a theater, we have a couple different locations. We have overstage and then in the house. And the defining feature in a proscenium theater, which dictates where the location is the proscenium, obviously, which is labeled on that picture. If we move to the right hand of the picture, that will be the house side. We have a couple different locations. Our front light locations are going to be referred to as beams or catwalks. And they are numbered as such that as you get further away from the proscenium, the number increases. So the first beam or catwalk closest to the proscenium is going to be numbered the first catwalk, and subsequently after that is the second catwalk. We also have positions in the house that are side light positions, and we refer to them as box booms. There can be multiple iterations of box booms as well. They are simply referred to as house right or house left, or stage right, stage left, depending on how that facility prefers. Now, going to the stage side of the proscenium, when we have a lighting position, we refer to those as electrics because we have electricity run to them. So very similarly to numbering in the house, numbering over stage starts closest to the proscenium and increases as we move further away. So the closest electric to the proscenium is the first electric, followed by the second and third. We also have a dedicated electric that has lighting fixtures on it simply to provide color for the cyclorama. That is commonly referred to as the cyc electric. And other fixtures that we hang to provide effects for the cyc may hang from that as well. We have other hanging positions. Those are not attached to electrics commonly, but they are hung from the supporting grid in the theater, and those are called side ladders. They are simply a position that would allow for hanging additional lights at a far side angle. And then as we move down, we have what are called dance booms or side booms. Next, we have a studio lighting grid. Typical grid height in a studio is going to be 15 to 20 feet. These lighting grids are also common in black box theaters or black box performance spaces, as they offer a lot of flexibility. In these systems, we're going to label the pipes similarly to how we would label a chessboard. So one direction of pipes are going to be lettered, and the other direction is going to be numbered. And, depending on what corner that facility wants to start on is where you would start. And if you have a light, let's say that first light closest to us is located at B2, so we know where to hang the fixture. And then we have event stage lighting positions. These are typically mobile or temporary systems, but can be installed as well. And they are going to use a truss system, again, because of that temporary nature. The typical hang height in an event stage is 25 to 30 feet, depending on the roof, if you're outside, inside, things of that nature. When we're dealing with truss in a small system, we're not going to number it. We're just going to call it by its location. So over the stage, we have the upstage truss, which would be the backmost truss, and then the downstage truss, which would usually be at the lip of the stage or maybe slightly on stage from there. And then the truss that is in front of the stage providing front light, we can call it the front of house truss or just simply the front truss. And then if we have lighting fixtures placed on the floor, we usually refer to them by their position on the stage: downstage right, upstage right, downstage left, upstage left, and so on. And with that, we have come to the end of this episode. If anyone has any questions, please feel free to contact me directly at bob.mentele@elationlighting.com. Now, these are just a few examples of typical lighting design layouts, but we always recommend consulting the services of an accredited lighting designer or system consultant when redesigning or specifying a new lighting system. This will ensure that you meet required industry standards and local code requirements as well. Please feel free to contact us here at Elation if you need any assistance in finding a local lighting professional in your area. Again, thank you for watching this lighting system design series episode, presented by Elation Lighting. Have a great day.